Welcome to this tutorial on using Google Cloud to protect your applications with a managed single sign-on proxy system. Today we'll explore how to secure a Kubernetes application using native Google Cloud technologies. This approach is both simple and effective. Let's start by understanding the concept before we implement it. Imagine we have a Kubernetes engine instance containing a basic deployment or pod. We expose this using a Kubernetes service. When someone tries to access this service through cloud load balancing, which is managed by Kubernetes Engine, we want to check that they are using an authorized Google Cloud Platform identity. These identities could come from Google directly or an integrated SSO system. In our example, we'll use Identity and Access Management, or IAM, to control access to the public load balancer, which in turn protects the underlying application. To begin, we'll create a new cluster in Google Kubernetes Engine. We'll choose a standard cluster instead of autopilot for simplicity, sticking with the default settings. You can increase the cluster size later if needed. We'll also activate the Cloud Shell, which we'll use to manage our resources. While our Kubernetes cluster is being set up, let's configure our OAuth credentials. We'll go to the OAuth Credentials page and set up our application for internal use. This means it will only work with identities from our Google Workspace or Google Identity Organization. We'll give it a name but leave the other settings as they are for now. Next, we need to create credentials. These will be an OAuth client ID and client secret for our web application. We'll set up the JavaScript and redirect origins later. After creating these, you'll see the client ID and client secret in the console. You don't need to memorize or write these down, as we can access them here when needed. As we wait for our Kubernetes cluster to finish setting up, let's prepare the resources we'll use to demonstrate this setup. First, we'll create a deployment resource. This will be a YAML file that defines an Nginx deployment with port 80 exposed. We'll use the latest version of Nginx and run 3 replicas. Think of this as the application we want to protect. We'll also need a service resource. This will be another simple Kubernetes resource that we'll call Nginx. It will select based on the app label we defined in our deployment and use port 80. Once our cluster is ready, we can authenticate with it and deploy these 2 resources. This will create 3 Kubernetes pods and a node port service. At this point, our setup is using private networking. We can use port forwarding to see what this would look like if it were accessible. Using the web preview feature in Google Cloud, we can access this private service while doing the port forward. You'll see the Nginx page, which represents our application that we want to make accessible, but only to authorized users. Now that we've seen our basic application, let's enhance our setup and add the necessary security layers. We'll start by updating our service resource. We need to add a Backend Configuration, which is a Google Cloud-specific resource. This tells the load balancer powering our application that we want to enable Identity-Aware Proxy on this backend. In our service specification, we'll add an annotation that points to this backend configuration. It will look something like this. We're saying that our backend config on port 80 is going to use the Nginx backend config we just created. To make our application publicly accessible but secure, we need to set up an Ingress. This Ingress will use a managed certificate resource, giving us an HTTPS endpoint for our application. We'll need to update our DNS records to point our chosen domain to this Ingress, allowing the certificate to be provisioned. Our Ingress resource will specify that we're using a Google Compute Engine load balancer. We'll include both our managed certificate and our front-end configuration for the Ingress. The default backend will be our Nginx service that we set up earlier and will force a redirect to HTTPS for security. We also need to set up a secret for our Identity-Aware Proxy. Let's consult the Google Kubernetes Engine documentation for the exact steps. We'll create a secret called IAP OAuth and specify our client ID and client secret. These are the values we got earlier when setting up our OAuth credentials. Now that we have all our resources defined, let's deploy them. Remember, you'll need to set up your domain to point to the IP address we get from this deployment via a DNS-A record. I'll do this DNS work off-screen as the process depends on where your DNS is managed. After deploying, we might see an error at first. This is actually a good sign. It means we're getting a valid certificate, but we haven't fully set up our OAuth yet. We need to set up our redirect URI. Let's grab the error details and use that whole string as our redirect URI in our OAuth setup. In our OAuth client credentials, we'll add this as a redirect URL. It might take a few minutes for this change to propagate, so be patient. Once that's done, when we try to access our application, we should see it attempting to authenticate us. We'll select our user account, but at first we'll probably get an access denied message. That's because we haven't added any users to our Identity-Aware Proxy setup yet. Let's go to our IAP service and add a principal. We'll use our own account as a test. For the role, we'll choose Identity-Aware Proxy Secured Web App User. We could add groups, domains, or service accounts here too, but for now, we just need to assign this role to give access. After setting up the IAP access and refreshing our application page a few times, we should finally see our protected website. In this case, we'll see the demo Notomatic.io website with access granted specifically to our user account. This demonstrates that our Identity-Aware Proxy is working correctly, allowing only authorized users to access our application. We'll provide all YAML and diagram files in the video description for your reference, reuse, and revision. If you'd like to support the channel, start a trial of our new design tool, linked in the description, and let us know what you think. Thanks so much for watching until the end, and please enjoy responsibly.